We are building on the last lesson that revolved around expected value. Expected value, again, was another name for mean, and one of the other main measurements that goes along with mean is standard deviation. So we are focusing today on finding standard deviation. Well, in order to find standard deviation, we first must find variance. And if you remember, variance is like finding the average of the squared deviations from the mean, which is a whole bunch of stuff that we're going to break down in steps. Variance, if you remember, was denoted as sigma squared, or you're going to see this in your book this unit, simply VAR for variance. This lovely formula, we're going to break that down in steps in just a few minutes. Standard deviation, if you remember, tells you how spread out the model is. And we find it by simply square rooting the variance. Standard deviation was sigma, or you're going to see in this unit, SD for standard deviation. So to find standard deviation, you simply square root your variance. So what we're going to do is we're actually going to use the examples that we used last class. So to break down variance and standard deviation, first step, create your probability model. If you remember, that's the table that just simply lists all of your probabilities and the outcomes that go with them. Next thing you got to do, calculate your expected value. That was what we learned last lesson. And then, and we've done this before, take each x value and subtract the mean. So that would be this little formula, x minus the mean. Once you've subtracted, you're going to square each of the results. All that squaring does, if you remember, if we square a negative, we end up with a positive. Once you've squared, then you're going to multiply each one of those answers by its probability. That would be this. Then you're going to add down the probability, or you're going to add down that last column to get the variance. So when we add, we end up with variance. And then finally, to get your standard deviation, you square root your variance to get standard deviation. So let's take a look at the exact same examples we were working on last lesson. So this goes back to the first example. This was the Lucky Lovers discount example. This is the data that we had already filled in our table last time. So if you remember, you could get a $20 discount, but the probability of that happening was 1 out of 4. You could get a $10 discount. The chances of that happening were 1 out of 12. Or you could get no discount at all and pay your entire bill, and the probability of that happening was 2 out of 3. So this is literally copied straight off of example 1. Now, the other thing that we need to carry along with us is our expected value. That was this guy right here. If you look back at our previous example, our expected value we found was 5.83. Okay, so that's all stuff from last lesson. So if we go through our table and we look at our little column headings, this first column that we need to fill in, we need to take each x value and subtract $5.83. So 20 minus 5.83 is 14.17. 10 minus 5.83 is 4.17. And 0 minus 5.83 is negative 5.83. Now, we're going to go over to the next column. If you remember, the main purpose for squaring was squaring gets rid of negatives. Now, you're going to start noticing on these problems the numbers are going to get ugly. So all we're going to do is simply write it as 14.17 squared. And we'll let the calculator do the work later, which means this is 4.17 squared. Now the last one, we know the squaring gets rid of the negative, so we're going to do 5.83 squared. We're just getting rid of that negative because we know it's gone. So now we're going to take the part that we just finished, which was 14.17, and we're going to multiply it by its probability. So we're going to multiply this by 1/4. Then we're going to do the next line. 4.17 squared times its probability, which is 1/12. And finally, 5.83 squared times its probability. Oops, I'm sorry. That's not 0. Let me erase that. Times its probability, which is 2/3. This last column here is the column that we're going to put in our calculator. So if you pick up your calculators, 4.17 squared times 1/4. We're going to do a plus sign there because we got to add down the column. 4.17 squared times 1/12 plus 5.83 squared times 2/3. The answer we get here is our variance for x. And if you round to 2 decimals, because it's money, you should get 74.31. Then, to get our standard deviation for x, we need to square root 74.31, and we get $8.62. And that's your standard deviation. So we're going to do the exact same thing with our next example. All right, so if you remember this example, this was the car repair for the air conditioner. So you had two options. The first option was the cheap recharge. That was $60, and its probability was 0.75. Then we had the more expensive repair job, which was $200, but that was only a 0.25 probability. And the expected value that we had found last time was a perfect $95. So we're going to start by taking each x and subtracting 95. 60 minus 95 is negative 35. 200 minus 95 is 105. Then if we keep following our instructions, all we got to do is square. That makes our negative go away. So we now have 35 squared and 105 squared. Super easy. Now we're going to keep following the instructions at the top. We're going to take what we just found and we're going to multiply it by 0.75. And this one, 105 squared, times its probability, which is 0.25. And pick up your calculators. 35 squared times 0.75 plus 105 squared times 0.25. And if you remember, this is going to give us our variance. So I got a rather large number. I got 3,675. Hopefully you got that as well. And to find our standard deviation, we just need to square root that answer. And so if you square root and round to 2 decimals, I get a standard deviation of $60.62. Hopefully you guys agree with that answer. So hopefully you're seeing that these are pretty easy examples once you've done the expected value. All right, so this last example, this was the one with which one? Oh, this was the computer one. If you had two new computers, you lost nothing, and its probability was 0.524. If you had one refurbished, you lost $100, and the probability was 0.419. And if you had two refurbished, they canceled their order, and that cost you $1,000, and its probability was 0.057. So let's go through the steps. What was our variance from example 3? Well, it was $99. So we're going to take each one of the x's and subtract $99. 0 minus 99 is negative 99. 100 minus 99 leaves you with $1. And 1,000 minus 99 leaves you with $901. Our next step, square each one of those numbers. So the negative changes to a positive when you square it. 1 squared and 901 squared. Again, we're not doing any calculator stuff till the very end. So now we're going to take 99 squared and we're going to multiply it by 0.524. Then we're going to take 1 squared and multiply it by 0.419. Then we're going to take 901 squared and multiply it by 0.057. And yes, all of the stuff that I'm writing down right now is what I want to see you write down. So now pick up your calculators. 99 squared times 0.524 plus 1 squared times 0.419 plus 901 squared times 0.057. This gives us our variance. I ended up with, hang on, I ended up with 551,408.8. Very large number. To find our standard deviation, we're going to square root that 51,408.8. And I got a standard deviation of, rounded to 2 decimals, 226.74. This one has a bigger standard deviation because look at your x values. Use 0, 100, and 1,000. They're very spread out. That's why the standard deviation is larger. And that's the end of today's lesson.